Okay, let's look at composite trig functions. I've chosen a couple examples to work for you just to help show you how to approach these problems. So let's look at the first one. We want to find the secant of tangent of inverse of square root of 3. So as you see, we've got parentheses. The way to approach this is we want to work inside the parentheses first and then go from there. So our first thing we want to do is we want to find the inverse tangent of the square root of 3. Now remember, when we find the inverse, our answer is usually always some kind of angle, so we're going to call that theta. Let's find that first. So let's go to the side. I'm going to work that, the inverse tangent. We're looking for the square root of 3. It equals theta. We can rewrite it. The tangent of theta equals the square root of 3. Okay, so the way we work the inverse tangent functions, or we want to find the theta that gives us square root of 3 when we take the tangent. So let's see, as you remember for inverse tangent, our angles, our thetas, somewhere are restricted between pi over 2 and negative pi over 2. But all you basically need to do is find the reference angle. So let's look over in our chart. Where is the tangent equal to square root of 3? And it is equal to the square root of 3 at pi over 3. So my theta is pi over 3. That's our reference angle. So very simply, since the tangent was positive square root of 3, we know that it is a first quadrant angle, and this would be pi over 3. Okay, that's our first part. So now let's go back to the original problem. And we're looking at the secant, and now we can replace the inverse tangent. We know that is pi over 3. So to find secant of pi over 3, we know that we can first find the cosine of pi over 3. Find the cosine of pi over 3, then flip. Okay, so this is not too bad. The cosine of pi over 3 is a first quadrant angle. As we know, we've drawn that out. It's a first quadrant angle, pi over 3. So we can just check our reference chart over to the right. What is the cosine of pi over 3? So here's pi over 3. Here's the cosine. We get 1/2. So the cosine of pi over 3, let's work it right here. The cosine of pi over 3 is 1/2 equals 1/2. Therefore, we can say that the secant of pi over 3 is you just flip the answer. That would be 2 over 1, which equals 2. 2 is my answer for the whole problem. Okay, for our second example, let's find the inverse sine of the cosine of 5 pi over 6. So just like the last problem, we're going to work inside out. So we want to find the cosine first, then we can find the inverse sine of that. So let's first look at the cosine of 5 pi over 6. This is just evaluating a basic trig function. So if you remember how we do it using the reference angle, is let's first locate where 5 pi over 6 is on the unit circle. And we know that 5 pi over 6 is a second quadrant angle right here. That's our theta, which is our 5 pi over 6. Okay, so since the terminal angle ends in quadrant 2, we know that it's quadrant 2. That means cosine in quadrant 2 is negative. So our answer should be some kind of a negative number. So let's look at the reference angle. The reference angle, let's see, of 5 pi over 6 equals pi over 6. What's the cosine of pi over 6? Let's check our chart to the side. Let's see. Pi over 6 is right here, and we're looking for the cosine. So we get square root of 3 over 2. Square root of 3 over 2. And that's cosine of pi over 6. But remember, we're in quadrant 2. Therefore, our angle, our cosine of 5 pi over 6 should be negative square root of 3 over 2. Okay, so that's our first part. So now let's go and finish the problem. Let's see. We had the inverse sine, right? Now it was the cosine, right, of 5 pi over 6. But we just found that was cosine of 5 pi over 6. We found that to be negative square root of 3 over 2. So now we're left finding the inverse sine of the negative square root of 3 over 2. Now, as you remember, for inverse sine, we are trying to find a value of theta such that the sine of theta equals negative square root of 3 over 2. So if you remember, for inverse sine, our angles are restricted between pi over 2 and negative pi over 2. We basically have quadrant 1 and quadrant 4. Okay, so if the sine is positive, it ends up being a quadrant 1 angle. If it's negative, it ends up being a quadrant 4 angle. So notice this, we have the sine of theta equals negative square root of 3 over 2, which is quadrant 4. So let's check our reference angle. Where is sine of theta equal to square root of 3 over 2? We see up here, it's square root of 3 over 2, the sine equals pi over 3. So my reference angle for theta is pi over 3. Okay, but remember my sine was negative square root of 3 over 2, which means it's actually a fourth quadrant angle. So instead of pi over 3, we have negative pi over 3. And if you looked at it on the graph, we would have this fourth quadrant angle of negative pi over 3. So negative pi over 3 is our final answer.